Hello, I am Rushikesh Kulkarni. In this video, we are going to discuss about iron carbide equilibrium diagram. Iron carbide equilibrium diagram is very much important in engineering, metallurgy and material science. This iron carbide equilibrium diagram tells us material behavior of iron with respect to percentage of carbon and temperature in degree Celsius. Here we have taken temperature in degree Celsius. Here x-axis of iron carbide diagram contains percentage of carbon, while y-axis contains temperature in degree Celsius. Here we are going to discuss about three invariant reactions. Okay, so there are 3 points on this graph. Okay, I had arranged these points here by by descending order of temperature. Okay, here first is peritectic reaction, second is eutectic reaction denoted by Et, and last is eutectoid reaction denoted by Eu. Here first of all we have to understand behavior of iron by adding some percentage of carbon and temperature. Okay, first of all, when we are adding very less amount of carbon in iron, then we are getting ferrite structure denoted by alpha. Alpha is ferrite structure. It is BCC this is BCC structure. It contains 8 atoms at the corner of cube and 1 atom at the center. So this is base centered cubic structure. It contains magnetic properties and maximum carbon solubility in ferrite iron is 0.025% carbon. Okay. Then second structure is austenite. By heating iron above 750 above 723 degrees Celsius, we are getting austenite structure. Okay, austenite is FCC structure actually. FCC is face-centered cubic structure. In a cube, at the corners it contains atoms, and at center of each face there is again atom. So this austenite face is FCC and it contains non-magnetic properties. Maximum carbon solubility in austenite structure is 2.1% carbon. Maximum carbon percentage is at 2.1 and it is happening at 1130 degrees Celsius. Maximum carbon percentage is 2.1 and it is happening at 1130 degrees Celsius temperature. Okay. Then our last structure is cementite. Cementite contains maximum carbon percentage in iron. Okay, here up to 2.1% carbon, we call that iron as steel. Now above 2.1% carbon, we know that that iron as cast iron. Okay, here up to 0.8% carbon, that steel is known as hypoeutectoid steel, and above 0.8% carbon is known as hypereutectoid steel. Okay, and at 0.8% carbon we know that eutectoid phase, eutectoid steel. Okay, first our invariant reaction is peritectic reaction. In peritectic reaction, it is happening at 1495 degrees Celsius temperature at 0.18% carbon percentage. Okay, here delta iron, this is again BCC structure. Here first of all iron is BCC, then it is going in FCC structure, then again it is going in BCC structure, delta iron phase. Here delta iron and liquid iron in liquid form are going to be converted into austenite. This point is very much important to understand peritectic reaction. Here delta iron and liquid are converting into austenite. Here solid delta iron and liquid iron are converting into solid austenite structure. Okay, then we are going for second reaction, that is eutectic reaction. Eutectic reaction is happening at 4.2% carbon percentage and at 1130 degrees Celsius temperature. Okay, here liquid phase of iron is converting into austenite and cementite. Gamma means austenite, and cementite is our Fe3C. Okay. This mixture of austenite and cementite is known as lead burite. Okay. This is lead burite. It is product of eutectic reaction. Okay. Here liquid phase is converting into two solids. In peritectic reaction, solid and liquid is converting into solid. In eutectic reaction, liquid is converting into two solids. Okay, and our last reaction is eutectoid reaction. Eutectoid reaction is happening at 0.8% carbon percentage and at 723 degrees Celsius temperature. Here, our austenite phase is converting into ferrite and cementite. Alpha means ferrite and then cementite. Here solid austenite is converting into solid ferrite and solid cementite. From austenite microstructure we are getting two microstructure, ferrite and cementite. In this way we had understood what is ferrite, austenite, cementite and lead burite, and three invariant reactions, that is peritectic reaction, eutectic reaction and eutectoid reaction. Okay. In our next video, we are going to understand what is martensite, bainite, trusite and sorbite. These all microstructure are related to the TTT curves. These four microstructures are related to time temperature transformation curves. These structures are very much important in heat treatment process. Again, here another microstructure is going to be considered as pearlite. We are considering this in our next video, giving brief idea here. Pearlite has pearl luster in its microstructure. Pearlite has pearl luster in its microstructure. It contains 87% ferrite and 13% cementite. Okay. Thanks for watching. Please like and share our video. Subscribe our channel. Thanks.